All right, guys, happy Friday. As Mr. Cole is still gone and I have class up at USD, we're going to watch a video today. So you get to hear my voice for the next probably 15 minutes. Good luck. So anyway, today we're going to talk about the volume of a pyramid. So volume at its most basic form is still always going to be the area of the base times the height. So you're taking whatever area you have on the bottom and you're multiplying it by how far you go up with that area. That works great for prisms and cylinders where they're figures that have two bases. They have a base on the bottom, base on top. The problem comes when you start to get into the pyramids, because a pyramid has just the one base and then all of those other four faces all come up to meet at a vertex instead of meeting at another base. So the volume of a pyramid, we need a special formula for, and that is going to be 1/3 the area of the base, which is still our big B, multiplied by the height. If you want to check out that formula, if you take a pyramid and a prism that have the same height and the same area of the base, you can fill that pyramid with water or sand or salt or whatever, okay? And if you dump whatever 3 of those pyramids into that prism, it'll fill the prism exactly. Okay, so that's where this formula kind of comes from. So let's look at that. And remember over here, your height is not, sometimes this is called a slant height. We'll talk about that later. But your height is the perpendicular distance to the ground. Okay, it's like when you're measuring your height, like to check for how tall you are, you stand up straight, right? You measure from the very bottom from the ground all the way to how tall you are, and you measure in a straight line. You don't measure at an angle like this, okay? So make sure that your height is always perpendicular to the ground. Okay, so let's find the volume of some pyramids. If you look at this pyramid, we have a triangular base. So since our base is triangular, we're going to need to use our formula that we have for the area of a triangle and use that in our formula for the volume. So the area of a triangle is 1/2 times the base length, little b, not big B, times the height. Okay? Since we want a big B in our formula, and that's just going to be the same thing this is, I'm just going to call that big B from now on. So big B is equal to 1/2 our base length here, which is 4, times our base height, which is 6. 1/2 of 4 is 2, times 6 is 12. So 12 is equal to our big B. Okay, if we look at our formula for volume, we got volume equals 1/3 area of the base times the height. We know the area of the base. We just found that. That's 12. Okay, we also know the height from our figure here, right? That's our perpendicular distance to the ground. That's going to be 9. Oops. Okay, so volume is going to be 1/3 of 12, which is 4, times 9, which is 36. And we need meters cubed. Our units are always in cubic units. So the volume of this pyramid with a triangular base and a height of 9 is 36 meters cubed. All right, let's do this next one. So we have a hexagon for a base. If you remember back to I think it was 11.3, we talked about how to find the area for figures that are regular, right? We talked about hexagons, pentagons, that kind of stuff. We had that formula, right? Area equals 1/2 ANS. So we're going to have to do the same thing first here, okay? We know our number of sides. It's a hexagon, so our number of sides is 6. We also are given our side length here, which is 12. The only thing we don't have is our apothem. So bear with me here. I'm going to try to draw a hexagon. We'll see how this goes. Yeah, not bad. Okay, Not exactly symmetrical, but, you know, close. So, that's a regular shape. If we take that central angle and divide it in two, right, instead of looking for the whole angle, we're just looking for this piece right here. Oh, that wasn't good. Try that again. Yeah. Okay. So we only want this angle up here, okay? Now the thing that we're going to do, remember, to find the whole central angle, we take 360, divide by our number of sides. That's 6. 36 divided by 6 is 60. We only want half of it, so we're going to divide that by 2 again. That's going to give us 30 degrees. So this angle up here is 30 degrees. We know the side length. Since this is a perpendicular bisector, this has to be 6. 12 divided by 2. Okay, we don't know the hypotenuse, but we really don't care at this point. We want to know the apothem. So there's two ways to do this. If you recognize it's a 30, 60, 90 triangle, you can do it that way. I'm going to do it with full-on trigonometry. So we have 30 degrees, and we have an opposite side, and we have an adjacent side. Opposite over adjacent is TOA. So we're going to take tangent of 30 degrees, and that's going to equal the opposite, which is 6, over the apothem. We need to times by the apothem on each side and divide by the tangent of 30 on each side, because we want A by itself. The A's will cancel, the tangents of 30 will cancel over here. We're going to have apothem equals 6 divided by tan 30. Okay, I already did that in my calculator. Maybe, there we go. So 6 divided by the tangent of 30, our apothem is going to be 10 point, I think it was 39. I would not round that yet. I just rounded it so it was easier to write. I would wait till the very end to round it. Otherwise, you probably will get the wrong answer when you go to do your assignment later. So we know our apothem. We can find the area of our base. So area of our base is going to be 1/2 ANS. Our apothem is 10.39. Again, use the exact. Don't use the rounded. Number of sides is 6 times the side length, which is 12. We're going to have 0.5 times, if you hit second and then the negative sign, second, negative sign, you get your answer. So the answer from the previous one. So to use that whole thing, it won't use the rounded one. So 0.5 times our answer times 6 times 12. So our area of that hexagon is 374.12. And that's centimeters squared. So now we have our big B, right? Area, this was area of a hexagon. I'm going to change that because that's really our big B. So big B is 374.12. Now we just need the height, right? We want the volume to be 1/3 area of our base times the height. We know the area of our base. That's that. We know the height too, right? That's that perpendicular line there. That perpendicular distance from the bottom to the top. That's 20 centimeters. Okay, so we want to take 1/3 of that area that we got times by 20. So, whoops. 1/3 is easiest if you just put parentheses around it. 1 divided by 3 times second answer, and then times by 20. Okay, so that gives us a volume for this pyramid of 2,494.15. So volume equals 2,494.15. And that'll give us centimeters cubed as a unit. Don't forget your cube. Don't forget your unit either, for that matter. okay? All right, that was a tough one, okay? This next one, pretty easy. So take a moment and try it on your own, and then all right, so I hope you got 400 centimeters cubed. Volume equals 1/3 times the area of the base times the height. That is how it always is for pyramids. So I plugged in what we knew. We have a square base. All these sides are congruent. Whoops, right there, right there, right there, right there. So since I know it's a square, we also have a right angle here, so we know it's a square even more. I know I can just take 10 times 10, right? Length times width, that's my area. So as I did here in green, 10 times 10 is 100. That's the area of the base. And then I know the height, because that's that perpendicular distance from the bottom to the top, is 12. So I take 1/3 times 100 times 12. That's 1/3 of 1200, which is 400. All right. I hope you guys got that one right. So let's look at this pyramid problem. So I think it's Khafre, but maybe it's coffee. I don't know. I'm not big on my ancient Egyptian names, but maybe you guys know better. So Khafre's pyramid had a height of about 144 meters and a volume of about 2,218,800 cubic meters. So find the side length of the square base. We know the height, right? Our distance to the bottom there from the top is going to be 144 meters. If you look at our formula, we have volume equals 1/3 times the area of the base times the height. We just said we knew the height, right? We can substitute 144 in for that. Okay, we also know the volume, right? We can take that volume out and we can put in our 2,218,800 number. It's a lot of volume. Okay, so I would combine like terms first. So I would take 1/3 of 144. Just kind of makes it easier. 1 divided by 3. Nope. 3 times 144. That's going to give me 48. So really I have 2,218,800 equals 48B, big B. Whoops, dropped the pen. All right. So at least I didn't drop the computer this time. Anyway, so we have 48 times our big B, our area of the base, is 2,218,800. So we need to divide each side by 48. Okay, when you do that, you get 2,218,800 divide by 48 gives you 46,225. So big B is 46,225. Okay, and that is meters squared. So it just wants one side length, okay? But the important thing to pick out here is we have a square base. Since the base is square, we know that some dimension, we'll just call it x, right? If we have a square base, that was kind of a square. Some dimension, we'll call it x, times itself again equals, what do we say, 46,225. We don't know what these are, so we'll just call them x for right now. But we know x times x has to equal 46,225, right? x times x is x squared equals 46 to 25. Okay, if you want to solve a square like that, you square root. If we square root x squared, we get x. If we square root 46,225, technically we get plus or minus, let me do it real quick, second square root, that is second x squared, and then do second answer, or you can just type it in either way. So that's 215. So technically we get x equals plus or minus 215. So we could be a positive 215 or a negative 215. But if you look at our unit, meters, we can't really have a negative 215 meters in real life, right? Especially not as a dimension. So we really just need 215 meters. So our side length, I'll abbreviate it SL, is going to be 215 meters. It's a pretty big pyramid. All right. Let's do the next one. Okay, we want to find the height. Again, volume equals 1/3 times the area of the base times the height. So we know the volume is 14. That equals 1/3 times the area of the base times the height. We don't know height, so I'm going to leave that alone for right now. But we can find out the area of the base really easy, right? The area of the base, we have a triangular base. If I color that in, we have a triangular base. Whenever we have a triangle, we're going to have 1/2 length of base times height of base. So big B is going to be 1/2 of 4 times 3. Big B is going to be 6 feet squared. So we can take out B, plug in 6. 1/3 of 6 is 2, right? 6 divided by 3. So 14 equals 2 times H. So you look what we have here, okay? You can obviously divide by 2 on both sides and get 7, right? If you reason through it, 2 times some number equals 14. Okay, you know that 7 times 2 is 14, so this H has to be 7. And like I said, you can still do, okay, divide by 2, you know, H equals 7. You'll get the same answer, but sometimes this goes faster if you just reason through it. That was an arrow, not a Z with a line through it, by the way, I think. Yeah, there we go. Okay. So, moral of that story, your height is 7. And it's 7 feet. All right, let's find the volume of a similar figure. Okay, remember similar figures are proportional, right? Every dimension is going to be proportional to itself. So I think the easiest way to start this one is to look at both pyramids and say, okay, I'm going to take the height of pyramid B and divide it by the height of pyramid A, because we know the height for both of them, right? The thing we're trying to find of pyramid B is the volume. So if I take height of pyramid B divided by height of pyramid A, I get 6 divided by 8. If I reduce that, it's going to be 3/4. Okay, so this is our K. That's our proportion that is what makes these two figures similar. Okay. Now, volume is a cubic measurement, right? You have a length, you have a width, you have a height. So if you multiply the length by 3/4, and you multiply the height by 3/4, and you multiply the width by 3/4, you've really multiplied by 3/4 3 times, okay? So if you want to find the proportion that keeps the volumes similar, you're actually going to have to take 3/4, or K, right, and cube both of them, right? Volume is cubed. Okay, so K to the third is equal to 27 over 64. All right, now you have the proportion that keeps the volumes similar. So you can take, we did pyramid B first over here, so I'm going to do that again. So volume of pyramid B over the volume of pyramid A, which we know is 96, equals our ratio that keeps these in check, right? Our proportion, which is 27 over 64. Okay, now we're going to multiply that out. So we have, come on, there we go. 27 divided by 64, divided by 64. That equals whatever that number is, okay? Now, I want to times by 96 to get rid of the 96 on each side, right? So times by 96. Times that by 96, I'm going to get 40.5. So the volume of pyramid B is equal to 40.5 meters cubed. Okay, the only thing that, the only real trick to that one there was making sure that your ratio that is like pyramid A to pyramid B, or I think we did pyramid B to pyramid A. Making sure that that ratio, since you're taking the ratio of the volumes now, you have to cube it, okay? If you think about it, I kind of talk through this, but here's what it looks like written down. You're taking length times width times height, right, to get volume, basically, okay? If you multiply this one by 3/4, you have to multiply this one by 3/4, and you have to multiply this one by 3/4. So then you're going to have length times 3/4 times width times 3/4, and then times height times 3/4. Okay, now you have 3/4, right? So since multiplication's commutative, you can pull those all out front. So 3/4 times 3/4 times 3/4 times length times width times height. Now 3/4 times 3/4 times 3/4 you can write as 3/4 cubed times length times width times height. We know length times width times height is volume, so we can substitute that in. So our volume has to be 3/4 cubed, which is then times by whatever the volume of the other one is. Okay, our proportion, when we get to the volume, our volume proportion is 3/4 cubed. Okay, that's kind of where that comes from. You know, if you found that really boring, hopefully you just skipped ahead. All right, so one last example here. Okay, we got finding the volume of a composite solid. Okay, we kind of got a house here, right? For A-Day kids, that was our Washington Monument problem. For B-Day kids, I think we did one. I'm pretty sure we did one of these, okay? But we didn't use the pyramid. So now let's use the pyramid part along with our knowledge from last class about prisms. So I'm going to split this up, okay? We have two different shapes here, right? We have our pyramid, and then we have our box, okay, our prism. Whoops, that one got away from me. Okay, I'm going to do green first. I'm going to do our prism. So I want the volume of the prism. That's going to be length times width times height, right? Area of the base, those are what big B is. Area of the base times the height. So volume of our prism. Look at that box. That was a terrible box. Okay, 6 times 6 is 36 times our height, which is 6. So volume of our prism is equal to 216 meters cubed. All right, now we need to find the volume of the pyramid. So volume of the pyramid that's going to be 1/3. Remember our formula, 1/3. Area of the base times the height. Our area of the base is going to be the same, right? It's still going to be 6 times 6. So volume of the pyramid is going to be 1/3, 6 times 6, which is 36. And then times our height. What is our height over here? Well, that's 6. So we can plug that in as well. Okay, 36 divided by 3 is 12. So volume of our pyramid is going to be 12 times 6. So the volume of the pyramid is equal to 72 meters cubed. Okay? Now, we have basically like the house part, and then now we have the roof part, right? Okay, if this is a house, we have like living area, I'll call it. Unless you live in the attic, then I'm sorry. You know, although sometimes it's nice, you know, in the winter it's warmer. So, you know, you got that going for you. Anyway, living area plus, I don't know why I said times, plus the roof, right? That's the volume of your house. Okay? So you got 216 plus 72. If we substitute in here, I'm going to say house equals a living area, which we said is 216, plus the roof, which we said is 72, or the attic, or whatever else you may call it. Okay, so the volume of our figure there, of our composite solid, is equal to 216 plus, whoa, I lost it. There we go, plus 72. Okay, 216 plus 72 is 288, and that is meters cubed. Whenever you see a composite solid like that, the easiest thing to do is just find the area of the base, or find the area of the one figure, find the volume of the one figure. Whoa, struggling hardcore here. Okay, find the volume of the first figure, find the volume of the second figure, add them together. All right, well, your assignment is on big ideas. It should probably be open by now. So get a good start on that. Work hard on it. Try to get it done. I think most of you probably can get it done before you leave class. And have a great rest of your Friday, a great weekend, and we'll see you next week.